Hello, and welcome to this Analyst Angle. I'm Bob LaLiberte, the principal analyst of theCUBE Research, and today I'm joined by Casey Kindiger, CEO of Grokstream, and Josh Kindiger, president of Grokstream. And today we're going to discuss the role of AI ops in the enterprise and maybe even beyond. So welcome, Josh and Casey.
Thanks,
Thanks,
Bob.
Bob.
Yeah, great to have you guys on. And it's such an important topic because we're seeing that AI ops is really becoming a lot more commonplace as organizations are struggling and trying to overcome with all that complexity that's associated with the modern and highly distributed environments, right? And really just surpassing the human brain's capability to be able to monitor and manage all of that. The good part is that AI ops, as it becomes more widely deployed, organizations are reporting that they're getting benefits from it, right? Surprise, surprise. In some recent research we just did, we found top three benefits organizations reported. One, driving greater operational efficiencies for their teams, which is always very important. Faster time to identify and faster time to remediate issues. So given the always on environment that everyone has, the ability to find an issue and fix it is going to be extremely important. And AI ops, really the goal of it is to help organizations move from that reactive to proactive and even predictive, if you will. But we know this doesn't happen overnight. And so that's why we wanted to come on today and talk with Grokstream. And Casey, I know in our prior conversations we've had, you've emphasized that journey that Grokstream has taken, going from anomaly detection into a fully functioning AI ops platform. So I'm wondering if you could share a little bit about that journey. What were some of the pivotal events that guided this evolution to the AI ops platform? And how did those events help shape your development strategies?
Oh, that's a great question. I think I'll start with an event that actually preceded Grokstream, and I think so. Really, the first pivotal event for us was a bad hypothesis that Josh and I made early in our career. We spent the better part of our 20s scaling up a consulting firm, the first company that we started together. And that firm focused on deploying sort of cutting edge technology to help large enterprises and service providers efficiently manage their growing networks and application stacks, right? So this is, think back the late 90s, early 2000s with the dot-com boom and so on. After like 6 or 7 years really grinding away at that, having deployed like well over 100 of these platforms for large enterprises, we kind of sat back and came to the realization that we had done a great job. We had made it possible for these companies to manage the large networks, keep their customers happy, keep growing the business. But we realized that it took a lot of talented engineers performing repetitive, low level tasks every day just to keep the lights on. And we didn't feel good about that. We really, after, a lot of hard work, hiring and training 120 plus engineers that were really, really smart, we didn't feel good about the outcome. We kind of sat back and hypothesized that the reason the engineers weren't automating, even though, I mean, come on, these guys had all the skills needed, right? They're developers, they're technologists. There's no reason that they spend 50% of their time, clicking buttons and sorting through routine tasks. We thought the reason that they didn't do it is they just didn't have enough time. And if we made it easier for them to put kind of what's in their brain into an automation platform, it's going to be nirvana. We're going to solve the problem. Everything's going to be automated and folks are going to be doing more interesting work from that point on. Turns out that was a bad hypothesis. We started a software company around that hypothesis that, um, by all intents and purposes, did very well. We were successful there, but it didn't really solve the problem. So what we realize is that that's a design trap. The idea that you can solve the problem without applying machine learning and deliver scaled automation without machine learning, it's a design trap. It just frankly didn't work and doesn't work, and that's why we don't have more automation in IT today. So like I said, our automation company was very successful. We sold it to Insight Venture Partners. But after we did that, we started thinking hard about how can we get out of that design trap. And that brings me to the second pivotal event, which is a little bit more exciting. It was a lunch that I had near Stanford's campus. And it really was where the future of Grok got started. Okay, we were exploring different approaches, trying to dig our way out of that trap. And I read a book called On Intelligence by a guy named Jeff Hawkins. Jeff, I don't know, have you heard of Jeff, Bob? Have you
I have not.
encountered him? He hasn't.
Yeah.
Okay, so he in addition to writing this really cool book, which I highly recommend, he is the creator of Palm Pilot. And after selling Palm Computing, he started this awesome research lab in near Stanford, and really dug into AGI, artificial general intelligence. He wanted to kind of solve that problem. But kind of the bottom line is, between the ideas in his book and of course, I, after reading his book, found a way to have lunch with the guy. And after the conversation over lunch that I had with him, I came to believe that biology can inspire the design of not just kind of algorithms, and AI models, but of artificially intelligent systems that can solve a whole variety of different kinds of problems. So after the lunch that Jeff and I had, um, the prototype anomaly detection algorithm that he had built with his team using some of the foundation models that Numenta had developed, um, that anomaly detection algorithm was named Grok. Uh, it became our first model in our portfolio, and Numenta became our first investor. So that was the second pivotal event, really, that in the birth of our company, and frankly, kind of drove our fundamental hypothesis. The two events together shaped every single phase of our development process, and I'll tell you how, or I'll give you an example of how, and that'll sort of describe. Um, you can imagine how iterations of our development roadmap evolve from there. So, in the early stages of our research journey, imagine 5 or 6 folks, some PhDs we would have in an office. We would find opportunities. We were always focused on how do we drive automation, right? We would find opportunities where we could deliver some value to customers, but it would require developing rule sets, kind of relying back on the old way of doing things. And okay, let me give you an example, like topology based inference, right? We can solve a lot of problems using topology based inference, but at every single one of those opportunities, every time we were sort of uh, uh, tempted to fall back on those, we chose the more difficult path of working through the problem methodically using AI and avoiding the trap. So, like, by using brain biology as our kind of core roadmap to designing intelligent systems, we worked to break down every single problem at each stage of our evolution, at each kind of phase of our development roadmap, and figured out what the best algorithm, the best technique, using the most modern AI sort of libraries to solve the problem at the time.
Got it. Yeah, I think that's fascinating. And as I mentioned at the start that this doesn't happen overnight. How long has this journey been for you? When did you get started with Rockstream?
So I started really the very beginning. Our research journey started 9 years ago,
Okay.
and we didn't even really offer a commercial beta for 3 full years of research.
Yeah, that's fascinating. It's interesting to see all of the AI companies that are obviously sprouting out now because it's a very hot space. But it's always intriguing to find the ones who are having the most success. Usually started close to a decade ago, and it's really been that continual evolution that's enabling you to deliver the value. The other thing I find really fascinating about your approach is that foundation in neuroscience kind of inspired technology, and I haven't heard too many other people talk about that. I know you brought up a little bit about how you implement that. Is that something, obviously that's fundamental to your architecture and to your capabilities. How does that, how do you translate that for an end user? How do you say that having this neuroscience basis and foundation, how does that deliver better results and outcomes?
That's a really, really good question. So I think the best way to answer it is to go back to kind of the initial conversations with Jeff and his team. So those guys were working on AGI, right? Artificial general intelligence, fundamentally a different problem than we're focused on. But while they aimed to replicate the human brain, we aimed to free humans from monotonous, time consuming tasks in enterprise IT, right? So the key principle that we latched onto was that biology is the best roadmap for modeling complex human behaviors. Jeff and his team worked hard to sort of take really drill into how the human cortex works and invent new algorithms that tried to rebuild the brain from the ground up. But after launching our Grok beta, we started to sort of apply neuroscience to the overall problem of network and IT automation. Instead of targeting the brain as an end in itself, we modeled the problems encountered at each step of the journey while thinking about the brain more of sort of a blueprint for thinking systems overall. We thought about sort of the systems in the brain that allow it to perform complex behaviors. Not so much we didn't care so much sort of to model the brain itself, but to use the brain as a blueprint. And I'll give you an example. The first problem we had to solve on our journey for IT and network automation was the volume, variety, and complexity of the operational data that like as IT has evolved, as networks have evolved, it's just exponentially grown, as we all know. Um, so if we kind of think back on the human brain, right? Every organism lives in a high resolution 3D environment, right? And five, multiple sensory organs consuming lots of different sensory data. The brain actually uses a lot of connected systems to process that observability data to eliminate the noise and then try to organize the information in a way that upstream systems can make sense of it and take action from it, right? So we took the same approach. And for example, like the foundation problem of that volume, variety, and complexity of noise, we just this is just like one slice of the problem. We use anomaly detection to pre-process the time series metric data, and we use associative clustering to segment the alert data, the anomaly data together, such that what we call them is detections. So each kind of detection or cluster of data is related to the same underlying cause. So we took the same kind of biological problem of sensory data. We looked at what algorithms were available to sort of do the same task that the brain does at each given step. And at each stage of our platform evolution, for every single problem that we encounter, we take the exact same approach. We stop before we try to solve it using kind of the old way. We look to how the biology, how evolution has solved the problem, and then we apply algorithms to do to solve that problem.
Cool. I really find that fascinating. And Josh, I know we want to get you in the conversation as well here. Uh, the interesting piece is you added all this neuroscience and you have all these different steps that's going along, but how does that impact an organization's ability to use this to scale and the extensibility of the platform across potentially a diverse IT environment? So, how do you, especially we talked about the enterprise and beyond, right? So how do you ensure Grok remains adaptable and efficient when it's expandable and it's expanding, sorry, to complex and multi-domain environments that might be encountered in an MSP or a CSP?
Yeah. So Bob, for starters, we continue to focus on being very agile, constantly innovating, and being able to consistently execute, right? And as Casey said, when we started down this path 8 or 9 years ago, we had made mistakes in the past. We had just exited a previous company. And he kind of mentioned this, but we've spent 25 years in the same space trying to solve the same problem. And the largest service providers, the largest managed service providers, the largest enterprises in the world. And from that experience, we knew that the platform needed to be extensible and the platform needed to be scalable. And one of the reasons that we took the time early on is, we didn't want to rush something to market. We knew that AI and ML was going to be able to help us solve this problem in a greater way than we've been able to in the past. So we started talking to a lot of our old customers, contacts that we had in the market, people that were executives in these very large companies, and asking them questions about how AI could be leveraged and what they were seeing from other tools in the market. And the first thing, really ties back to extensibility. And we would hear consistently that one of these companies had either adopted an approach or adopted one of these early kind of entrants in the market, and that they were 3 or 4 years down the road, and they were being told that this approach was artificial intelligence. But they would look at us and they would say, "Look, we still have a team of people writing rules, or we're being told that we have to use a topology, or have to have a mature CMDB, or we need to do some type of tag-based or scope-based grouping." And they would look at us and they would say, "Hey, where's the artificial intelligence in this?" Right? We think to solve this problem holistically, we need a true AI approach. So as Casey said, we spent a lot of time early on building this pipeline, this platform, innovating in and around not only the models and how to solve the problem in a true AI approach, right? But also making sure that we had the right technology in the pipeline that would allow us to do it in a real-time fashion. Because when you think about how Grok goes about this, right? Grok sees every single alarm that's firing as a symptom, right? And that symptom is basically described by the node or device or CI that is alarming that. We need to know what generated the alarm and what is the description of the alarm. And in these large environments, we're talking about millions of symptoms, and Grok being able to capture and understand in its brain how related each of those unique symptoms are to every other unique symptom that it's seen, right? So we're talking about models that can be millions of unique alarms or symptoms and patterns by millions of alarms of unique symptoms and patterns. And it's a very complicated. Our data science team, with Casey at the head, had to do a lot of deconstructing, legacy approaches that were out there and breaking it down so that we could operationalize it in a real time kind of pipeline and deliver that capability real time, because these operations centers need to know that those problems are occurring and so that they can resolve them as quickly as possible. So I would say that that those kind of 3 pillars that I talked about before, being agile, constantly innovating, that continues today. While we spent that time early on, every day we're thinking about, we're talking to customers, we're learning for new ways to extend our AI ops capabilities kind of beyond the traditional AI ops use case into things like being able to proactively detect problems, right? When you look back at Grok's capabilities, doing things like extending into major incident management. So Casey talked a lot about the early days and how we worked to really solve the problem before we pushed to market, and that that agility, that constant innovation, that consistent delivery continues and will continue with us as we go to market in the future.
Yeah, I think that makes a lot of sense. And I know I started off by asking you about the extensibility in large organizations and so forth. But if I'm a customer out there today watching this, what if I want to get a little right? Sometimes that's a little bit daunting, right? Scale is where you get to, but there's got to be a starting point. So maybe we can talk a little bit also about what a typical customer journey would look like from that deployment perspective, right? And talk about a little bit, once they deploy it, when do they start getting any kind of tangible results? And one of the things that I've always been keen on with AI ops is that there's the technology aspect of it, and then there's the cultural aspect of it. And that cultural piece is, there's some resistance, and there's what I refer to as a time to comfort, if you will, with these AI ops technologies. So can you talk about how you get this deployed, when they start seeing results, and is there anything that you're doing in particular that's helping to accelerate that time to comfort with the operators so that they're comfortable leveraging, utilizing the results that they're getting from Grok in their day-to-day work?
Yeah, absolutely. So it's funny that you kind of use the word time to comfort. Oftentimes when we start the sales process with these guys and we talk about us being true AI, I hear the word magic all of the time. Josh, this sounds great, but man, it sure sounds like magic, right? And we've had to work very hard explaining our capabilities and really coming up with a methodology that starts in the sales process to build that confidence with our customers and get to that time to comfort. And almost every time it starts with the pilot. And honestly, we have a couple different ways we can go down that path. We're happy to do a live pilot. As you know, we're fully multi-tenant in the cloud. It's very easy for us to set up an integration to any of the monitoring and observability tools that are out there. So, if we do a live pilot, we set up an integration and Grok starts learning. Other customers want to kind of see value in a pilot quicker. And we also have the ability to kind of do something offline. All of our models are available to us in these toolkits that our pre-sales team can use. So we go into a customer environment, they can provide a year's, 6 months, 3 months worth of historical data. We can load that, pre-train Grok's brain, and then run all of the results on the last week. Now, with either path, whether we're doing a live pilot or we're doing an offline pilot, once Grok's brain is trained, the time to value is very quick, right? Unlike some of our competitors where you have to worry about building use cases or writing rules, Grok just learns, right? All we need access to is that observability data and your historical incident management data. And through this process, through the pre-sales process, once we collect the data, as we present the results back to them, there's always this element of learning where they're evaluating the Grok calls the groups of alarms detections. So they'll be evaluating the detections, providing their feedback. And we've also learned that we have to provide a lot of information to them when we perform the detections, right? So we provide a level of explainability so that an operator can understand in a human readable kind of format why Grok grouped this, how many times this problem has happened, how many times this problem has resulted in an incident. And then also we can tell them how that problem was resolved historically, right? So we give them all of the information that they need. We help them quickly understand and build confidence in the platform. Ultimately, we've worked extremely hard to get past that whole, where's the magic, Josh? So that they understand in detail, why Grok's doing what it does.
Yeah, I like that. And I'm curious if you have any kind of averages. I know my favorite expression when I talk about this time to comfort is the old Tootsie Pop commercial where the two kids ask the wise owl, how many licks does it take to get to the center of a Tootsie Pop? And he does the 1, 2, and then crunch and says 3, it's 3. So I'm always curious to ask, in your experience working with, how many times does it take for that to come up, share the results and so forth, for organizations to really become comfortable and say, you know what, this thing knows what it's doing. I trust it, and I'm just going to, for all these events like this that come up, I'm trusting it implicitly.
Yeah, that's good. Let me talk about that in a couple different ways.
Okay.
So when our customers have historical data and we can pre-train our brain, we'll get, let's just say 3 months of data or 6 months of data. We can even use a year if you have it. Then they're going to see immediately day one when Grok forms a detection, right? There are kind of different levels of confidence that we can provide. So when Grok forms a detection, if Grok tells you that these exact same 5 alarms have occurred 10 times historically, and we group them historically, and they also resulted in an incident with the same close notes, fix action, your level of confidence is immediately there, right? So when we have historical data and the luxury of pre-training Grok's brain, then that time to value, that time to confidence is very short. And in an example, I'll use our managed service provider customers as an example, right? Because we'll deploy, Grok in a large managed service provider, and let's say they have 500 customers on the platform, and they add a new customer. Grok's there is no historical data. They onboard it, they start monitoring that customer's environment. Day one, Grok will start showing value. Now, Grok is only as smart as what it's seen. So it takes time in that scenario for Grok to mature. So the good news is no one touches anything. That customer gets added to the monitoring stream. Grok recognizes it. Grok trains its brain. It will immediately start grouping alarms. But it takes time for it to mature. So at the end of the first week, you can imagine that we're probably compressing the alarms by maybe 50%. By the end of the first month, we're in that 65% range. Into the second month, we're 75%. By the end of the third month, we're in that, mature kind of 85 to 95% range. So, when Grok hasn't seen data historically, then, it takes a little bit longer for us to mature, but we will show value immediately, basically day two. And that's seen every day in our managed service provider customers as they onboard more and more of their customers. No one touches anything. Grok spins up its models for that specific customer and starts showing value.
Yeah, that makes a lot of sense, and it makes sense giving the foundational neuroscience that you're putting in and giving it that time to learn, but it continuing to learn, getting smarter and smarter as it gets more information, as it's able to collect more information. Yeah, I think that makes a lot of sense to me, and it's really interesting when I've even talked to some of your customers and so forth, and the interesting piece is that you see organizations trying to get out of that reactive mode and get into more proactive and predictive. Easy for me to say. I'm wondering if you could talk about any examples where you've seen Grokstream having an ability to enable organizations to make that leap, to go from just being reactive firefighting to get to more proactive and even predictive and being able to solve problems before, right? If you're saying you're seeing the all the alerts that come in a certain, be able to group and sequence them, are there any pre-groupings that would indicate something's about to happen and enable organizations to predictively, eliminate an issue before it actually occurs?
Yeah, yeah, for sure. So I want to start off by just kind of talking about some of the challenges around being proactive and predictive, right? Because I don't think people really understand. When we think in terms of being proactive, predictive, preventative, there isn't a one size fits all. There are multiple approaches that work, and we've learned that kind of the hard way through trial and error. When we think in terms of the first area that we look to be proactive is around our clustering, right? And when we walk into customers' environments today, and I'm sure you've seen this, but almost every company that I walk into, when we talk about their monitoring data, we find that they're filtering around 95% of the signal that they receive, right? So we'll go into customers. Sometimes they call it NOC visible, right? Or command center visible, and basically they'll filter all of the alarms that fire and clear within 5 minutes, or alarms that are low severity, right? And we figured out early on that the reason they're doing that is because there's a massive amount of noise, and you can't write enough rules, you can't hire enough people to process all of that data. So they've been forced to kind of focus on the critical stuff. Well, by doing that, you're immediately reactive, right? How can you be proactive? So that's the first problem. The second problem is, we like to believe that everything is predictable, and it's not, right? A small percentage, and I don't know if it's 10 or 20 or 30%, but oftentimes in our customers' environments, things just break, right? And there isn't signal, there isn't alarm signal that allows us to kind of to predict and ultimately prevent those things. It just happens. They break for whatever reason. So, when we think in terms of prediction, because of our background with anomaly detection, we started with the temporal data, the time series data set, and we got really good at identifying in environments where that time series data existed. We got really good at identifying and tuning algorithms to predict the metrics, the threshold violations that were most likely to result in an incident. And what we found is that less than 7 to 10% of those alerts that ultimately become incidents are predictable. So small percent, but that's kind of the first area that we target in our customers' accounts. And of course, they were disappointed because they want to be able to predict and prevent more things, right? So that led to kind of us looking more closely at how we were clustering and that noise that was being suppressed, right? So in talking to our customers about opening up that noise, because the way Grok works is Grok forms a detection. That detection is a group of alarms that related. Those unique alarms or symptoms basically create a state of a problem, and those exact symptoms are labeled and tell us what the issue is or what the issue is going to be. So now, as we open up, again, no rules, there's no work in grouping these things. Grok just does it because it has a true AI approach. We open up the other signal. Grok starts grouping lower severity alarms that were ignored that may be fired and cleared very quickly. That becomes early warning. And then when we label that current state, Grok learns and is able to, and does, start telling customers, hey, we've got 4 low severity alarms, but in 30 minutes, there's an 80% chance that we have a problem and you need to do something about fixing it, right? So that's the second kind of way that we help our customers be predictive. And the third way, the most recent, is I mentioned earlier, kind of this idea of having proactive problem identification. And we've learned, and looking back as Grok has been used in our customers' environments, Grok recognizes some of the same problems that occur again and again. And now we've deployed a new algorithm in our pipeline because we continue to innovate that allows us to predict a problem. If I've seen an incident that's happened every 2 days for the last 30 days, I can make a prediction and say, hey, there's an 80% chance that this incident is going to happen at this time in this 6-hour period, in the next 2 days. That kind of talks a little bit about how we go about deploying that
Yeah.
proactive predictive nature for our customers.
Yeah, no, I think that's fascinating, and it almost seems counterintuitive, but it makes sense to, especially the part about opening up to get all the alarms, right? Because everyone's like, oh, there's so much noise. Just give me the real, what's real. But in order to get to that point where you're being more proactive and predictive, you need to be able to take everything in, get all the alarms in, so you can see everything that's going on and be able to model that. So that makes a lot of sense. All right. We're getting close to the end here. So, Casey, I want to go back to you for our final question. Um, what's next for Grokstream, right? What do you see coming down the road? How do you envision the broader IT landscape adapting to a lot of these AI-driven operations and AI ops?
Yeah, I mean, a lot of the focus, the kind of the hype in our space, in the IT space, is sort of, you know, developers using AI to generate code and that sort of thing. We think about it differently. We look forward and we see a time where there are far more engineers doing creative engineering work and a much smaller number of engineers tending to the health and well-being of the infrastructure. And the way that's going to happen is by applying platforms like Grok to solve this fundamental automation problem. And what we're almost there, Bob. We're like at the final stage, the tip of our research pyramid. I think the cap on our pyramid is how do we make it seamless for a small number of specialists to interact with our AI platform. And our, as you can probably imagine, our approach, our strategy, and our research in the last 2 years has been very focused on tackling that problem using LLMs. Um, and in the first iteration, this kind of augmented AI interface, if you will, we've branded Grok Guru, and our first version of Grok Guru we launched earlier this year. And the use case is really simple. It's to the first version was just to summarize the ML output in a way that's more consumable for humans, so they can take action faster, be more effective. Right? We're thinking much bigger. So fast forward a year, our next version is going to be, maybe Q1, early Q2 next year. And in addition to making the kind of intelligence that's embedded in our AI platform available to specialists, we're also going to wrap in all of the knowledge articles, vendor knowledge articles, everything that can be kind of encapsulated and consumed by an LLM, and superpower that interaction with the knowledge and experience that the AI platform has garnered over time to just keep driving down the number of specialists that are required to keep the lights on and keep the systems running optimally.
Yeah, I think that makes a lot of sense. I mean, certainly there's a lot of talk about tying in LLMs, multiple LLMs, to be able to gather that information and be able to deliver it up. So glad to hear, and then can, as you said, driving up that operational efficiency for organizations. Listen, I want to thank you both for coming on. This has been a great talk. I really enjoyed it. I love hearing about the neuroscience aspect of what you're doing and how it's learning about how you're trying to, in order to become more predictive and proactive, you need to actually open up and get more of the alarms in that so many people are trying to silence. I love that part of it, and the knowledge that you've gained by working with these organizations. So, but unfortunately, it's all the time we have for now. So, thank you both for joining me.
Thank
Thanks,
you,
Bob.
Bob. It's really fun.
Awesome. And thank you all for watching this Analyst Angle on the role of AI ops in the enterprise and beyond. For more information on Grokstream, please visit their website.